Hey everyone, welcome back to the channel, and in today's video we will be solving starter 67 some problems. And let's begin the first problem, whose title is Stood of King. And let's read the statement. And this is a simple problem. The statement is saying that King loves to go on tours with his friends, and he has n cars that can seat up to 5 people and m cars that can seat 7 people each. And we have to determine the maximum number of people that can travel together in these cars. An input format contains number of test cases, and each case has two integers n and m, which are basically number of cars of 5-seater and 7-seaters. Okay, and we have to output the maximum number of people, and the input format is, yeah, you can see for first case there are 4 cars which can seat up to 5 people and 8 cars which can seat 7 people. So just multiply 5 into n and 7 into m and then add their product and output. You can read all the explanation here, and this is a simple one-liner, two-liner code. Yeah, just inputting and calculating a into 5 plus b into 7 and printing their sum. Let's begin the second problem, whose title is minimum number of ones. And the statement is saying that your teacher gave you an assignment given an integer n and construct a binary string which consists binary strings means only 0 and 1 element it contains. Yeah, b1 up b1 b2 up to bn of length n, such that this condition holds true. Maximum value of bi and next element, which is bi plus 1, is 1, and for every I from 1 to n minus 1, and we have to determine minimum number of ones we need to construct that binary string. Yeah, that's all. And the input format is t, which is number of test cases, and n, which is length of binary string. And we have to output, these are constants, very simple, 10 to the power 3, and we have to output minimum number of ones required. So first case, let's take 6. If we take 6, then our binary string can be 0 1 0 1 and 0 1. So here these 3 ones are used. Yeah, we can also use this, because if we calculate these two max will be 1, these two max will be 1, and for similar up to n. But here we used 6 ones and here we use 3 ones. So in this case our answer will be, of course, 3 ones, and we can not choose less than 3 ones in this case. So just your answer will be ny2, because we are taking 2 elements. So yeah, that's all for this question. Also for this case our answer will be 8 by 2, which is 4, 2 by 2, which is 1, 3 by 2, which is also 1, greatest integer function. And you can see the simple one-liner solution here. Just output n by 2. Hope you understand this also. Let's move to the third problem, which is counting problem. And the problem statement is saying that you are given an array A which consists of all elements a1 a2 up to an, and it is possible to partition A into two non-empty subsequences. So what is the subsequence? Which means after deleting some element, but you don't need to change the order. For example, if I choose this can be a subsequence 0 1 0, this all will be subsequence. After removing this, it can also be a subsequence. You can read the article here, what is subsequence, you can see here. For example, b e and e, choosing these 3 values b, e and e, this is subsequence. Z is subsequence of y, and also b, e and e, z is also subsequence of x, which means subsequence is generally after removing some elements without changing their order. Yeah, we have to make two subsequence s1 and s2 such that the sum of all the elements in s1 and sum of all the elements in s2 and their product is odd. And here s1 is basically sum of all the elements of string 1, and s1 and s2 must be non-empty and every elements of A must be either in S1 or S2, and S1 and S2 must be disjoint, which means no elements common. And in input format is T, which is number of cases, test cases, and each case consists of N, which is number of elements in the array, and N elements. Let's take the first one, which is 1, 1, 2, and 2. Our array here is 1, 1, 2, and 2. So if we take these two as S1 and these two as S2, so the sum of all the elements in S1 will be 3 and S2 will also be 3, and after multiplying them our product will be 9, which is odd. So how we do that? So first just count odds, and odds not be 0 and odd should be even. Just two case, just to check these two. If these all satisfy, print yes, otherwise print no. For example, in this case we have how many odds? We have one is odd, only one odd, and the number of odd elements is 1, and yeah, number of odd is also an odd, so that in this case our answer is no. And if we write on this, our elements in array is if we do this, you know that odd plus odd is even. So if we add odd and even, which means yeah, odd and even is also even. So here in this case 1 plus 2 is even, and for product we need two odds. We want just two odd numbers so that our product will be odd. We want this one. So after adding 1 and 2 our answer will be even. This is E. Our answer is even, and adding even to even answer will be even, even to even answer will be even. So in this case we can't get two odd numbers, so that in this case our answer is no. And if we change any value to if we change any value to any odd number, let's say this, after changing the value we can plus these two, this will become 3, and just I am trying. Yeah, and remaining will sum up to 9, 9, 17, 27, and their product will be 81, and this is odd. Yeah, and number of odd in this string is this is odd and this is odd. Number of odds is 2, this is even, so that we get our solution. You can see the code here, just taking input and counting, and counting number of odds, and just checking if odd is not 0, which means odd. If it is 0 and AND operation, our this whole value will become 0. So just applying logical AND with odd and not odd and 1. This is basically checking if this is odd. If odd, I I am changing the value to even, and if this whole becomes true, our answer is yes, otherwise print no. Hope you also understand this, and let's move to the next one, which is expensive steps. And the statement is saying that there are n into n grid with row numbered 1 to n from top to bottom and columns numbered from 1 to n from left to right. And then the cell at intersection of ith row and jth column is denoted by ai, just like matrix. And Sefi is standing at position x1 y1 of this grid, and he wants to reach position x2 and y2. And to achieve this, he can either travel horizontal or vertical. So just traveling one row down, one row up, one column left and one column right. These four types of move is possible. And however, Ceph does not need to stay within the grid, which means we can go beyond our grid, and that is he can choose to go outside if he so wishes. And the cost of horizontal and vertical step is 0, and if both starting and ending are square lie outside the grid, if both starting and end point are outside grid, the cost is 0, otherwise one move cost 1. And we are supposed to formally suppose Ceph takes one step from xy to x dash y1 in one move. If xy lies within the grid, the cost of each step is 1, and if x dash y dash lies within the grid, the cost of this step is also 1, and if both lies beyond the grid, the cost is 0. And we have to minimize the cost to reach the destination, which means x1 y1 to x2 y2. And input format consists of t number of test cases, and each case has n, which is n into n grid, size of grid, x1 y1 initial position, and x2 y2 final destination. And we have to minimize the cost and output the minimum cost required from traveling to x1 y1 to x2 y2. And these are the constraints, large one. And let's take the first case, 3 1 1 2 3. Here n is 3, x1 y1 is 1 1 a starting point, and x2 y2 is 2 and 3. Okay, let's make our grid. Yeah, initially this is the initial position 1 1 and 2 3. This is the final destination. So to reach this, we can either travel from 1 1 to 1 2. This will cost 1, this will cost 2, and final 3. So our cost will become 3, and the next option is we can go beyond the cell. So after traveling from here to beyond the cell, this will cost 1 1, and after this I can travel or hold the column in 0. So here our cost is still 1, and we can reach here in also 0. This will also become 0, and from at this point we have spent only 1, and from reaching the destination we have to come inside the grid, and this is at the end point. So just this will cost from here to here 1. So our total costing is cost with escape. If we use escape, our cost will reduce to 2. So in this case our answer will be 2. So we have to just implement this logic, and yeah, just check if both are outside, output 0, otherwise just minimum of cost or escape cost. And yeah, you know at this point how to calculate escape cost, and your costing will just absolute value of these two, x2 minus x1 plus absolute value of y2 minus y1. this will be your absolute this will be your normal costing, which means traveling inside the grid. So in this case 2 minus 1 is 1 plus 3 minus 1 is 2, which means 3. This is your costing if you travel inside the grid. Otherwise you will choose your escape route, go beyond your limit. Yeah. Let's see the code solution. Just taking input, and yeah, I am here checking if points are outside grid. Just checking here if points are outside the grid, which means a will be less than 1. Our grid starts with 1s, which means a will be upside 1, which is less than 1. Otherwise a will be more than n. And for same y1 should be less than 1 or y1 should be more than n. This is the n, more than n, and same for x2 y2. Yeah, just checking if both points are outside the grid, checking for initial point and then checking for final point, and if both are outside, then our AND operation will yield 1, and if this is true we will output 0. Otherwise, yeah, you can also return. Otherwise I am calculating x escape, which means to escape from x, how many money I have to spend. So minimum of a, which means x1, and absolute value of n minus a plus 1, and then if I choose to escape from row, then just checking this, and if I choose escape route from column, just checking the next one, minimum value of b or n minus b plus 1, and same for y escape, these two values, and then calculating their cost, x escape plus y escape. In this case this one plus this one, these two values, and then calculating our normal costing, which means travel inside grid, and just outputting the minimum cost of cost with escape. Hope you also understand this. These are basically observation based problems. And let's move to the next problem, which is maximum angriness. And the statement is saying that Elias and Bob were playing a game yet again, but this time Bob already lost the game and now he wants to take the revenge. And Bob saw a jigsaw puzzle which was solved by Elias and decided to jumble the puzzle piece again. And there are n puzzle pieces in a line numbered from 1 to n in increasing order, which means sorted. And he has k minutes before Elias catches him, and Bob can swap any two pieces of the puzzle. And each swap takes 1 minute, and so Bob can make at most k swaps. And AI denotes the piece in the ith position after Bob finishes making his swap. And Eli's Angriness is defined to be the number of pairs ij such that I and j lies between 1 to n, and j is always greater than I, and ai is lesser than aj, which means in decreasing order. And Bob would like to make Elias as angry as possible. So he asks you for help. If he performs his swaps optimally, what is the maximum angriness he can achieve? So we have to just output maximum number of alternates we can achieve so that Elias becomes angry. And how can we alter? Just by swapping two values at most k times, which means k swap, and the input format is t, which is number of test cases, n total number of elements, which means puzzles here, and k number of minutes, which means total number of swaps we can made. And constraints are quite large, so if you try to get your work done using brute force, you will get TLE, because the time limit is 1 second, and if you use big O of n, this will also give you 10 to power 9 and this will, yeah, 10 power 9, which is t into 10 power 9 big O t, which is number of test case, and test case will also be quite large here. Test case is, yeah, 10 power 5. So here replace t with 10 power 5, it will give you 10 power 14, and this will require at least 2 seconds, but here we have given 1 second, so this will give you big TLE. So what can we do here? We just need some maths to solve our problem, and let's take the first case, which is 7 and 3. N is 7 and k is 3. So initially our array will look like 1 2. This will be our array. This is in sorted, this is sorted. So after first term, yeah, and see here k is 3, which means we can do 3 swaps. So just I am choosing these two values from inside. So after swapping this, all remain same, 2 3 4 5 6, and these two values will be swapped, 7 and 1. And for second term, just I am choosing these two, first these two values, second these two values, because these endpoints values are swapped, 7 1. These two values are being swapped on the second term, and for the final term, just swap these two values. So after swapping this, if I start from I from here, our pair can be 7 6, and this will satisfy the condition, which means I is here assume 0 and this is 1, and a0 is larger than a of I. So yeah, this will satisfy the condition. So how many pairs we can get? 7 6 can be pair, 7 5 can be, 7 5 can be also a pair. So from 7 we get 6 pair, from 6 we can get 5 pair, from 5 we can also get 4, from 4 we can get 3, from 3 we can get 2, and from 2 we can get 1, and after adding all this you will get 21 such pair, which means here this is the answer here. So how can we do that? So first ask yourself how many max pairs, how many max pairs you can get. So here in this case we have swapped till n by 2. Here n is 7, so n by 2 will yield 3. So after swapping these n minus 2 values, you will get how many combinations? This will give you NC 2 combinations. Okay, so if you choose maximum number, and yeah, you can also achieve more swap, but after swapping more values you will end up in sorted array again. So you can maximum make n by 2 swaps. N by 2 swaps I am listed here. Yeah, n by 2 swaps, and your max answer can be NC2, which means combination with 2 elements, and we have total choices of n, so NC2. And after decomposing this formula, we will get n factorial by 2 factorial into n minus 2 factorial. This is basically PNC based problem, just to test your mathematics knowledge, and you can also choose brute force approach, but you will need at least 5 to 6 seconds. So yeah, we can simplify this n into n minus 1 into n minus 2 factorial by 2 factorial into n minus 2 factorial. So these two will be cancelled and we will remain with n into n minus 1 by 2. This is our max value. This is your max value. So if k is, we can maximum swap n by 2 elements, and after swapping n by 2 elements we can maximum achieve this number of angriness. So what if k is less than n by 2? So in this case we have swapped some mode elements, so just subtract these mode elements from max minus combination of extras. Just swap. And what is here extras? Your extra elements are n minus 2 into k, because n is total number of elements, and in one swap you are choosing two elements. You are choosing two elements in one swap. So just remove the extras, and like this you can also calculate the permutation of combination of extras, and then your final answer will be max, which we calculated here right side, minus extras combination. Max is here. This is your max. This is your max value. This is your max. This minus extras combination. And yeah, this is quite tricky one. You can see the implementation here. Just inputting n and k, and your max combination will be nc2, and calculating the max value as nc2, decomposing nc2, we will get n into n minus 1 in by 2, just you see here, and then making our answer and storing answer as max value, and then removing the extra combination, just checking if we have achieved mode angriness but we have k minutes. So these remove extra, and what is extra? N minus 2 into k, these number of elements, and what are the combinations made from these elements? These are the extra. Just remove the extra combination from the answer, and here answer is max value. After removing extra combination, your answer will be just answer. So this is the last solution. So hope you guys understand this also. So if you guys found this video helpful, please subscribe to the channel if you are new to the channel, and thanks for watching. See you in next video.